This is Eric Topol, and I'm really thrilled. I've been so excited to have the chance to speak to Melanie Mitchell again. Melanie is a Davis Professor of Complexity, professor at the Santa Fe Institute in New Mexico, and I look to her as one of the real, not just leaders, but one with balance and thoughtfulness in this high velocity AI world of large language models that we live in. And just by way of introduction, the way I got to first meet Melanie Professor Mitchell was through her book, Artificial Intelligence, a guide for thinking humans. And it sure got me thinking back, I think, about 4 years ago. So welcome, Melanie.
Thanks, Eric. It's great to be here.
Yeah, there's so much to talk about, and you've been right in the middle of many of these things. So that's what makes it especially fun. I thought we'd start off a little bit of history because when we both were writing books about AI back in 2019, publishing, the world kind of changed since. And in November, when ChatGPT got out there, it kind of signaled that there was this thing called transformer models. And I don't think many people really know the difference between a transformer model, which had been around for a while, but maybe it hadn't come to the surface, versus what were just the deep neural networks that ushered in deep learning that you had so systematically addressed in your book.
Right. Yeah. Transformers were kind of a new thing. I can't remember exactly when they came out, maybe 2018, something like that,
Right.
from Google. They were an architecture that showed that you didn't really need to have a recurrent neural network in order to deal with language. So that was one of the earlier things, and Google Translate and other language processing systems, people were using recurrent neural networks, networks that sort of had feedback from one time step to the next. But now we have the transformers, which instead use what they call an attention mechanism, where the entire text that the system is dealing with is available all at once. And the name of the paper, in fact, was "Attention is All You Need." And that by attention is all you need, they meant this particular attention mechanism in the neural network. And that was really a revolution and enabled this new era of large language models.
Yeah, and as you aptly pointed out, that was 5 years ago that attention is all you need, and then it took like 5 years for it to become in the public domain of ChatGPT. So, what was going on in the background? You think?
Well, the idea of language models, that is, neural network language models that learn by trying to predict the next word in a text, had been around for a long time. We have, we now have GPT-4, which is what's underlying at least some of Chat GPT. But there was GPT-1 and GPT-2, and you probably remember that. And all of this was going on over those many years. And I think that those of us in the field have seen more of a progression with the increase in abilities of these increasingly large language models. That has really been an evolution. But I think the general public didn't have access to them, and ChatGPT was the first one that was generally available, and that's why it sort of seemed to appear out of nothing.
All right. So it was kind of the inside world of the computer science kind of saw a more natural progression, but people were not knowing that LLMs were on the move. They kind of were stunned that, oh, look at these conversations I can have, and how humanoid it seemed. And
Yeah.
you'll recall there was a fairly well publicized event where a Google employee back, I think last fall, was, I don't know, put on suspension, ultimately left Google because he felt that the AI was sentient. Maybe you'd want to comment that because that's kind of a precursor to some of the other things we're going to discuss.
Right. So, yeah. So that one of the engineers who was working with their version of uh, uh, Chat GPT, which I think at the time was called Lambda, um, was having conversations with it and came to the conclusion that it was sentient. whatever that means, you know, that it was aware, that it had feelings, that it, experienced emotions and all of that. Um, and he was so worried about this, and he wanted, I think he made it public by releasing some transcripts of his conversations with it. And I don't think he was allowed to do that under his Google contract, and that was the issue. But yeah, and that made a lot of news, and Google pushed back and said, no, no, of course it's not sentient. And then there was a lot of debate in the philosophy sphere of what sentience actually means, how you would know if something is sentient, and yeah, and it's kind of gone from there.
Yeah, and then what was interesting is then the Microsoft research group published this Sparks paper where they said it seems like it has some uh, artificial general intelligence AGI qualities, and they're writing a research paper which is kind of making the same claim to some extent, right?
Um, well, that's a good question. I mean, intelligence is one thing, sentience is another. There's a question of whether, how they're related, because
Right.
or if they're related at all, and what they all actually mean. And these terms, this is one of the problems, of course, these terms are not well defined. But I think most people in AI would say that intelligence and sentience are different,
Mhm.
that intelligence, something can be intelligent or act intelligently without having any sort of awareness or sense of self, or, feelings, or whatever sentience might mean. So I think that the Sparks of AGI paper from Microsoft was more about this, that saying that they thought GPT-4, the system they were experimenting with, showed some kind of generality in its ability to deal with different kinds of tasks. And this contrasts with the older fashioned AI, which typically was narrow, only could do one task, could play chess, could play Go, could do speech recognition, or could, generate translations, but they couldn't do all of those things. And now we have these language models which seem to have some degree of generality.
Now that gets us perfectly to a important nature feature last week, which was called the Easy Intelligence Test that AI chatbots fail. And it made reference to an important study you did. First, I guess the term ARC, abstract and reasoning corpus, I guess that was introduced a few years back by Francois
Chalet, yeah.
Chalet, yes. And then you did a concept arc. So maybe you can tell us about this because that seemed to have a pretty substantial gap um, between humans and GPT-4.
Right. So Francois Chalet is a researcher at Google who put together this set of sort of intelligence test like puzzles, uh, visual reasoning puzzles that tested for abstraction abilities or analogy abilities. And he put it out there as a challenge. A whole bunch of people participated in a competition to get AI programs to solve the problems, and none of them were very successful. And so, what our group did was, we thought that the original challenge was fantastic, but one of the problems was it was too hard. It was even hard for people, and also it didn't really systematically explore concepts, whether a system understood a particular concept. So, as an example, think about, the concept of two things being the same or two things being different. Okay, so I can show you, two things and say, are these the same or are they different? Well, it turns out that's actually a very subtle question, because when we say the same, we can mean sort of this uh, the same size, the same shape, the same color. And there's all kinds of attributes in which things can be the same. And So what our system did was it took concepts like same versus different, and it tried to create lots of different challenges, puzzles that required understanding of that concept. So these are very basic spatial and semantic concepts um, that were similar to the ones that Cholet had proposed, but much more systematic. Because this is one of the big issues in evaluating AI systems is that people evaluate them on particular problems. Like, for example, I think a lot of people know that Chat GPT was able to answer many questions from the bar exam. But if you take like a single question from the bar exam and think about what concept it's testing, it may be that ChatGPT could answer that particular question, but it can't answer variations that test the
Mm-hmm.
same concept. So we tried to take inside of this uh, ARC domain, abstraction and reasoning corpus domain, look at particular concepts and say systematically, can the system understand different variations of the same concept? And then we tested these problems on humans. We tested them on the programs that were designed to solve the ARC challenges, and we tested them on GPT-4. And we found that humans way outperformed all the machines. But there's a caveat, though, is that these are visual puzzles, and we're giving them to GPT-4, which is a language model, a text
Right,
only
right.
system. Now, GPT-4 has been trained on images, but we're not using the system that can deal with images because that hasn't been released yet. So we're giving the system our problems in a text-based format rather than like giving it to humans who actually can see the pictures. So this can make a difference. So I would
What
say our results are preliminary.
what do you think will happen when you can use inputs with images? Do you think that it will equilibrate? There'll be parity, or there still will be a gap in that particular measure of intelligence?
I would predict that there will still be a big gap,
Hmm.
but I guess we'll see.
Well, that's what we want to get into more. We want to drill down on the biggest question of large language models, and that is, are they really, what is their level of intelligence? Is it something that is beyond the so-called stochastic parrot or the statistical ability to adjudicate language words? So there was a paper this week in Nature Human Behavior, not one that normally publishes these kind of papers, and as you know, was by Taylor Webb and colleagues at UCLA, and it was basically saying for analogic reasoning, making analogs, which would be more of a language task, I guess, but also some image capabilities, that it could do as well or better than humans, and these were college students. So just to qualify, they're not maybe they're not fully representative of the species, but they're at least some learned folks. So what did you think of that study?
Yeah, I found it really fascinating and kind of provocative. And it kind of goes along with a many. There's been many studies that have been applying tests that were kind of designed for humans, psychological tests to large language models, and this one was applying sort of analogy tests that psychologists had done on humans to to large language models. But there's always kind of an issue of interpreting the results because we know these large language models most likely do not think like we do.
Hmm.
And so one question is like, how are they performing these analogies? How are they making these analogies? So there's when you're evaluating, so this brings up some issues with evaluation when we try to evaluate large language models using tests that were designed for humans. One question is, were these tests at all actually in the training data of the large language model? Like, had they, these language models are trained on enormous amounts of text that humans have produced. And some of the tests that paper was using were things that had been published in the psychology literature.
Hmm.
So one question is, to what extent were those in its training data? It's hard to tell because we don't know what the training data exactly is. So that's one question. Another question is, uh, are these systems actually using analogical reasoning the way that we humans use it? Or are they using some other way of solving the problems?
Mm.
And that's also hard to tell because these systems are black boxes. But it might actually matter because it might affect how well they're able to generalize. If I can make an analogy, um, usually you would assume that I could actually use that analogy to understand some new situation by analogy to some old situation. But it's not totally clear that these systems are able to do that in any general way. And so, I think these results, like these analogy results, are really provocative and interesting, but they will require a lot of further study to really make sense of what they mean. Like
Yeah.
just like when you give when the Chat GPT passes a bar exam, you might ask, well, and let's say it does better than most humans. Can you say, well, can it now be a lawyer? Can it go out and replace human lawyers? I mean, a human who passed the bar exam can do that, but I don't know if you can make the same assumption for a language model because it's the way that it's answering the questions and the way that it's reasoning might be quite different and not imply the same kinds of more general abilities.
Yeah, that's really vital. And something else that you just brought up in multiple dimensions is the problem of transparency. So we don't even know the specs, the actual training, so many of the components that led to the model. And so by not knowing this, we're kind of stuck to try to interpret it. And I guess if you could comment about transparency seems to be a really big issue. And then how are we going to ever understand when there's certain aspects or components of intelligence where there does appear to be something that's surprising, something that you wouldn't have anticipated, and how could that be? Or on the other hand, why is it failing? So, what is transparency the key to this, or is there something more to be unraveled?
I think transparency is a big part of it. Transparency meaning, knowing the what data the system was trained on, sort of what the architecture of the system is, um, uh, what other aspects that go into designing the system. Those are important for us to understand, like how these systems are actually work and to assess them. But people, there are some methods that people are using to try and kind of tease out the extent to which these systems have actually developed sort of the kind of intelligence that people have. So there was a paper that came out also last week, I think, from a group at MIT, where they looked at several tasks that were given that GPT-4 did very well on. That seemed like certain computer programming, code generation, mathematics, some other tasks. And they said, well, if a human was able to generate these kinds of things, to do these kinds of tasks, some small change in the task probably shouldn't matter. The human would still be able to do it. So, as an example, in programming, generating code, there's this notion that like an array is indexed from zero. The first number is indexed as zero, the second number is indexed as one, and so on. So, but some programming languages start at one instead of zero. So what if you just said, now change to starting at one? Probably a human programmer could adapt to that very quickly. But they found that GPT-4 was not able to adapt
Mm,
very
mm,
well.
mm.
So the question was, is it being able to write the program by sort of picking things that it has already seen in its training data much more? Or is it actually developing some kind of human-like understanding of the program? And they were finding that to some extent it was more the former than the latter.
So when you process all this, do you lean more towards because of the pre-training and the stochastic parrot side, or do you think there is this enhanced human understanding that we're seeing a level of machine intelligence, not broad intelligence, but at least some parts of what we would consider intelligence that we've never seen before? Where do you find yourself?
Yeah, I think I'm sort of in the center.
Okay, that's good. That's
Everybody loves
good.
to describe themselves as a centrist, right? Uh, I don't think these systems are, stochastic parrots. They're not just sort of parroting the data that they've been trained on. Although they do that sometimes, you know. But I do think there is some reasoning ability there.
Hmm.
There is some, what you might call intelligence. It's but the question is, how do you characterize it, and how do you the most important thing is, how do you decide that that these systems have a general enough understanding to trust them?
Right.
you
Right.
know in your field, in medicine, I think that's a super important question. They can outperform radiologists on some kind of diagnostic task, but the question is that because they understand the data like radiologists do, or even better, and will therefore in the future be much more trustworthy? Or are they doing something completely different that means that they're going to make some very unhuman like mistakes? And I
Yeah.
think we just don't know.
Well, that's an important admission, if you will. That is, we don't know, and as you're again, uh, I think really zooming in on for medical applications. Some of them, of course, are not so critical for accuracy because you, for example, if you have a conversation in a clinic and that's made into a note and all the other downstream tasks, you still can go right to the transcript and see exactly if there was a potential miscue. But if you're talking about making a diagnosis in a complex patient, that can be if we see hallucination, confabulation, or whatever your favorite word is to characterize the false outputs. That's a big issue. But I actually really love your professor of complexity because if there's anything complex, this would fulfill it. And also, would you say it's time to stop talking about the Turing test? That retire? It's over with the Turing test because it's so much more complex than that.
Yeah, I mean, one problem with the Turing test is there never was a Turing test. Turing never really gave the details of how this test should work, right? And so we've had Turing tests with chatbots, since the 2000s, where people have been fooled. It's not that hard to fool people into thinking that they're talking to a human. So I do think that the Turing test is not adequate for the question of, like, are these things thinking? Are they robustly intelligent?
Yeah, one of my favorite stories you told in your book was about Hans Clever, um, and the basically faking out the potential that there was this machine intelligence with that. And yeah, I think this is so apropos. A term that is used a lot that a lot of people I don't think fully understand is zero shot or one shot. Or can you just help explain that to the non-computer science community?
Yeah. So in the context of large language models, what that means is, um, so I could. So do I give you zero shot? Means I just ask you a question and expect you to answer it. One shot means I give you an example of a question and an answer, and now I ask you a new question that you should answer, but you already had an example. Two shot is you give two examples. So it's just a matter of, like, how many examples am I going to give you in order for you to get the idea of what I'm asking.
Yeah. Well, and in a sense, if you were pre-trained unknowingly, it might not be zero shot. That is, if the model was pre-trained with all the stuff that was really loaded into that first question or prompt, it might not really qualify as a zero shot in a way, right?
Yeah, right. If it's already seen that, if it's
I
learned,
think we're
if it's
getting
seen that in its training data.
right, right, exactly. Now, another topic that is related to all this is that you participated in what I would say is a historic debate. You and Jan LeCun, who I would not have necessarily put together. Uh, I don't know that Jan is a centrist. I would say he's more, on one end of the spectrum versus Max Tegmark
Stigmar, yeah.
and Yoshua, how do you say?
Joshua Bengio.
Bengio, Yashua Bengio, who was one of the three notables for a Turing Award with Jeffrey Hinton and Jan.
Yeah.
So you were in this debate. It was the Musk, I think, Musk debate, not
Monk
Monk,
debate.
not Monk. I was going to say not Musk, right? Monk debate. Yeah. The Monk debates, which is a classic debate series out of, I think, University of Toronto, or
Yeah,
yeah,
that's
yeah.
right.
And it was debating, is it all over? Is AI going to? And obviously, there's been a lot of this in recent weeks, months since ChatGPT surfaced. So, can you kind of give it? I tried to access that debate, but since I'm not a member or subscriber, I couldn't watch it, and I'd love to actually. But can you give us the skinny of what was discussed and your position there?
Sure. Yeah. So actually, you can access it on YouTube.
Oh,
For free.
good.
Yeah,
Okay,
it's free.
good. I'll put the
So
link in for this. Okay, great.
yeah. So the resolution was, is AI an existential threat? Okay, but an existential meaning human extinction. So pretty dramatic, right? Uh, and there's been this debate actually has been going on for a long time. Since the beginning of the talks about this, the quote unquote singularity, right? Uh, and there's many people in the sort of AI world who fear that AI, once it becomes quote unquote smarter than people, will be will lose control of it. We'll give it some task like, solve solve the problem of carbon emissions, and it will then misinterpret or mis sort of not care about the consequences. It will just sort of maniacally try and achieve that goal, and in the process of that, for accidentally kill us all. So that's one of the scenarios. There's many different scenarios for this, you know, and debate. The debate was very a debate is kind of an artificial, weird, structured discussion where you have rebuttals and try, but I think the debate really was about sort of should we right now be focusing our attention on what's called existential risk, that is that some future AI is going to become smarter than humans and then somehow destroy us, or should we be more focused on more immediate risks, the ones that we have right now, of um, like AI creating disinformation, fooling people into thinking it's a human, magnifying biases in society, all the risks that people, are experiencing immediately, right? Or will be very soon. And that the debate was more about sort of what should be the focus of our
Mm,
attention,
mm, mm.
and whether we can focus on very shorter immediate risks, also focus on very long-term speculative risks, and sort of what is the likelihood of those speculative risks, and how would we even estimate that. So that was kind of the topic of the debate.
So did you all wind up agreeing then that you'd be
No,
scared, or where did it land?
well, I don't know. I you know it interestingly, what they do is they take a vote at the beginning of the
Mm,
audience,
mm, mm.
and they say, like, how many people agree with the resolution, and 67% of people agreed that AI was an existential threat. So it was two-thirds. And then at the end, they also take a vote and say, like, what percent of minds were changed, and that's the side that wins. But ironically, the voting mechanism broke at the end. So technology, for the win.
So there wasn't a post-debate
So
vote.
they did do an email survey,
Oh, oh,
which is, I think,
no,
not
no,
very
you
good.
can't compare that.
Yeah.
No.
So technically our side won,
Okay.
but I don't take it as a win, actually.
Well, I guess another way to put it, are you afraid? Are you scared?
So I'm not scared of, like, super intelligent AI getting out of control and destroying humanity. I think
Right,
there's a lot of reasons why that's extremely unlikely.
right.
But I do fear a lot of things about AI. Some of the things I mentioned, I
Yes,
think are real threats, real dire threats to democracy,
absolutely.
using that, to our information ecosystem, how much we can trust the information that we have. And um, also just, to people, losing jobs to AI. I've already seen that happening,
Right.
and the sort of disruption to our whole economic system. So I am worried about those things.
Yeah, yeah. No, I think the inability to determine whether something's true or fake in so many different spheres is putting us in a lot of jeopardy, highly vulnerable, um, but perhaps not the broad existential threat of the species. Yeah, but serious stuff for sure. Now, another thing that's just been of interest of late is the willingness for at least one of these companies, Meta, to put out their model um, as an open Llama 2, I guess, to make it open for everyone so that they can do whatever specialized fine tuning and whatnot. Is that a good thing? Is that a game changer for the field? Because obviously the computer resources, which we understand, for example, GPU used over 25,000 for GPT-4, 25,000 GPUs, and not not many groups or entities have that many GPUs on hand to do the base models. But is having an open model like Meta's available, is that good, or is that potentially going to be a problem?
Yeah, I think probably I would say yes to both.
Okay, okay,
Because it is a mixed bag. I think ultimately, we talked about transparency, and open source models are transparent. I mean, I don't think they actually have released information on the data they use to train
right,
it,
right,
so that it lacks that transparency. But at least, if you are doing research and um, trying to understand how this model works, you have access to a lot of the model. It would be nice to know more about the data it was trained on. But so there's a lot of big positives there, and it also means that the data that you then use to continue training it or fine tuning it is not then being given to a big company. Like, you're not doing it through some closed API like you do for OpenAI. On the other hand, these, as we just talked about, these models can be used for a lot of negative things, like spreading disinformation and so on,
right.
and giving sort of making them generally available and tunable by anyone presents that risk.
Yeah,
So I think there's an analogy, I think, with, like, genetics, for example, or disease research, where I think there was the scientists had sequenced the genome of the smallpox virus, right? And there was, like, a big debate over, should they publish that,
mm,
because it could be used to like create a new smallpox, right?
Right.
But
Right.
on the other hand, it also could be used to develop better vaccines and better treatments and so on. And so I think there are, any technology like that, there's always the sort of balance between transparency and making it open and keeping it closed. And then the question is, who gets to control it?
Yeah. Who gets to control it and to understand the potential for nefarious use cases, the
Yeah.
worst case scenario? Sure. Uh, well, I look to you, Melanie, as a leading light because you are so balanced and, you don't, the centrist thing about you is what I have the highest level of respect. And so that's why I like to read anything you write or where you're making comments about other people's work. Are you going to write another book?
Yeah, I'm thinking about it now. I mean, I think kind of a follow up to my book, which, as you mentioned, like your book, it was before uh, large language models came on the scene and before transformers and all of that stuff. And I think that there really is a need for some non technical explanation of all of this. But of course, every time you write a book about AI, it becomes obsolete by the time it's published.
That's what I worry about, and that was actually going to be my last question to you, which is, where are we headed? Whatever GPT-5 and on, and it's the velocity so high. Um, where can you get a steady state to write about and try to, pull it all together, or are we just going to be in some crazed uh, zone here for some time where things are moving too fast to try to be able to get your arms around it?
Yeah, I mean, I don't know. I think there's a question of like, our can AI keep moving so fast? We've obviously it's moved extremely fast in the last few years, and but the way that it's moved fast is by having huge amounts of training data and scaling up these models. But the problem now is it's almost like the field has run out of training data generated by people, and if it go if people start using language models all the time for generating text, the internet is going to be full of generated text rather than
Right,
human
right.
written text. And it's been shown that if these models are sort of trained on the text that they generate themselves, they start behaving very poorly.
Mm.
So that's a question, is like, where's the new data going to come from?
And there's lots of upsetness among people whose data are being used,
Oh, sure.
understandably. And as you get to, is there a limit of, there's only so many Wikipedias and internets and hundreds of thousands of books and whatnot to put in that are of human sourced content. So, do we reach a plateau of human derived um, inputs? That's really fascinating question. Perhaps things will not continue at such a crazed pace, so we can. I mean, the way you put together a guide for thinking humans was so prototypic because it was so thoughtful and it brought along those of us who were not trained in computer science to really understand where the state of the field was and where deep neural networks were. We need another one of those, and you're no one. I nominate you to help us to give us the right perspective. So, Melanie, Professor Mitchell, I'm so grateful to you. All of us who follow your work remain indebted for kind of keeping it straight. You you don't ever get carried away, and we learn from that. All of us. It's really important because there's so many people on one end of the spectrum here, whether it's doomsday or whether this is just stochastic parrot or open source and whatnot. It's really good to have you as a reference anchor to help us along.
Well, thanks so much, Eric. That's really kind of you.